Hi, I'm Jeff. Welcome back to the channel. I've been wanting to experiment with ring making a little bit. Now, I'm not a jeweler and I'm not even a machinist. I'm just a guy with a little shop. But I lost my wedding ring sometime last year. Truthfully, it's probably behind a piece of furniture in my house. We'll find it here when we move. But I feel naked without it, and you know, it's a symbol. It means a lot to us. So I've been wanting to experiment making rings, and I'm going to try that out of stainless steel for this one. There's a lot of work holding processes and finishing procedures that I'd like to at least try and see what I can get away with. And so we'll do some learning in this.
So I've got this piece of stainless steel. This is 17.4 and it's 1 inch in diameter. Now I just cut off a little piece here. This is actually a lot fatter than I'm really going to need it to be. But this will allow me to grip it inside the chuck to do a couple operations to begin with. Now the first thing I'm going to do here is just basically face it off. This isn't supremely important. This isn't really a precision piece. But this will help for the center drilling operation. Now I can go ahead and center drill it. And then I can run it through, and I'm starting with just a 1/4 inch drill bit here. And then I'm going to go ahead and follow that up with a 3/8 drill. With that hole done, I can just go in with my little tiny boring bar, and even though this doesn't go all the way through, it'll go deep enough to open this to the diameter that I want, which is 0.794 inches, or an American-sized 10.5 ring. Now I'm flipping it around because, like I said, the boring bar didn't go all the way through, but I can just face off this last little piece, and then we will have a through bore through the entire workpiece. And then just a little bit of a chamfer. Now for the next operation, I'd actually like to do some grinding on the inside of this ring. Now to do that, I've got a homemade grinder mount for the lathe. This holds a flex shaft rotary grinder, basically a really fancy Dremel tool. I made a video of it, so you can click the link and check that out if you're interested. Now what I'm going to do here is basically start grinding on the inside of the ring. I'm using this is a diamond bit. And this will allow me to take very, very, very fine cuts that not only polish out the inside, but also really dial in that final size. Though I don't do it on camera, every once in a while I'm stopping, pulling the ring out of the chuck, and actually fitting it to my fingers so that I can see if it's actually comfortable. This is the most in any project where I've used this grinding tool mount, and I gotta say, I'm actually really pleased with it. It has come out nicely, and it did exactly what I wanted it to, which is to do a very, or at least relatively precise grinding operation. Just taking a Dremel to something is usually a very imprecise operation. However, this really left me with a nice surface, really even, and, you know, pretty darn accurate. One thing to note in something like this is that I started slow because with two things rotating in this, something could go bad quickly. Additionally, as you'll notice, I have a paper towel down on the ways of the bed. because very fine metal particles as well as grinding dust are thrown during this, and it's already bad enough for the chuck. I do not want it on the ways of the bed either. Needless to say, a lot of cleaning is required if you're going to be doing something of this nature. You want to cover up as much as you can and then be very diligent about cleaning what you can't cover up. After the grinding was complete, I put a buffing wheel in our little rotary attachment to bring out a final polish on the inside of the ring. I've got a really mild polish in here because I don't want to be flinging that around inside the chuck or inside any parts of the lathe. So just a little tiny bit of polishing compound to really brighten that up, and I hope I could bring that out here in this shot. Now with the inside done, we're going to make another mandrel or arbor or whatever you want to call it. This will be made to the exact internal diameter of the ring, so I can glue it on here and work on the outside of the ring. Now this is very necessary because I will need to work on all of the outside of the ring, and I can't have it encumbered by the chuck jaws. I'm using a cutoff tool, a parting tool, to take basically the excess part of the ring off. The ring was far larger than it needed to be. And as you can see, it would stick on the cutting tool, which there's a lot of wiggle in, but it still stayed solid on the mandrel. It was the weirdest thing. It would sometimes slip, but the glue wasn't entirely broken. That's a new one on me, and I ended up having to switch tool holders for this cutoff tool. The one that came with my quick change tool post does not hold a cutoff tool very securely at all, so I actually had to put a cutoff tool holder in a standard quick change tool holder, if that makes sense. You can see it here. It's horrendously offset from the actual tool post. But I finally got through this parting tool. The thing about it is once I switched to those T-type cutting tools that are only 40 thousandths wide, I actually get a really good job doing parting in the cutoff process, as it's like right there. But the tool holder is just as important as any other part of the equation. After that groove has been made, I'm going to do a little bit of facing here just to make a separate definition in diameters, because we're going to have to take down the diameter of this one a little bit. With that cutoff piece sticking out a little bit, I can knock it off of its glued part on the arbor. And I'm just using a really cheap screwdriver for this. And then we can face off the edges of the ring and bring it to its final width. And I'm taking this a little bit deep to give myself some clearance in that aluminum mandrel. You can see I'm actually cutting a bit of a groove into the aluminum, and that's fine. With that done, we can go to the fun part, and this is actually shaping the ring. Now, this is something you need to be very careful about, working with a file on the lathe. As you can see, my hands, I'm holding them overhand and apart from the chuck and being very, very, very aware of where they are at all times and where the file is, because it doesn't take much for that file to get caught on a jaw or the workpiece or something. It could be sent flying into you. Something could catch you if you have a watch or a ring on, ironically, or something like that. So this is a huge safety banner here, working this close to the actual part on the lathe. But working by hand on the lathe, conversely, is actually pretty rewarding if you do it safely. As you can see here, I've got a really nice round over I'm starting to polish with abrasives. I'm going up, and those are probably bits of sandpaper a little small, truthfully. And anytime you're using abrasives, once again, on the lathe, I cover the ways because that's going to throw grinding dust everywhere. Now, finally bringing it up, this is 600 grit sandpaper. And we're getting a really, really, really nice polish there. Now all we need to do is free it from the arbor with a flame. And I'm using a hand scraper to get the last bits of glue out of the inside, as well as to kind of take off that burr around the edge. Now the next thing I'd like to do is actually heat blue this, and to do that I'd like to make a bluing tray. Now this is a technique that I've seen the channel Clickspring do, so I want to really give him a lot of credit for giving me the idea and inspiration for this. To make the tray to do the bluing here, I'm taking a block of aluminum, and first we're going to square up the sides. This isn't too difficult of an operation in the mill, and honestly, I love every opportunity I get to use the mill. It's just more time on the mill. Once it's relatively square and parallel, now we can go into the center, and we're carving out a dish, or a pocket. This is just 1 inch by 1 inch, and I'm actually just going off the dials and not even really looking at the part while I'm cutting this. And it's basically, right now we're doing the precision equivalent of a nut dish. So it doesn't need to be precise, it just needs to be basically a pocket halfway deep into our part. A really fun and great exercise for playing around on the mill, by the way. This will hold particulates in it that will serve as a medium for the heat to transfer through evenly, in this case will be brass shavings. The brass shavings will go in this pocket that we're machining, and then the ring will go in that, and that'll be held over heat. The brass shavings, I just machined down a piece of scrap brass with a little plastic bin underneath, which, you know, it's as safe as you want it to be. And then we're going to get a propane torch going and hold the part in this little tray to heat blue it. Now, there are many explanations of how this works, but basically as the metal heats to a certain temperature, which is just above 600 degrees for most steel, it will start refracting light at a different rate. Once again, Clickspring, Chris there, explains it far better than I could. After a lot of heating here, I actually didn't get hot enough, and part of the big problem is that I used aluminum for the tray, and aluminum is a very good conductor. It also has a really low melting point, so it started softening before the metal actually got hot enough to blue. So huge lesson learned here, and a little bit of a waste in cutting the aluminum, but not really because it was mill time, and I actually got this gorgeous bronze finish. I was disappointed at the very first, but then when I actually looked at the ring, it's a really deep and beautiful golden bronze, and I'm actually really pleased with this for a steel finish. The ring fits very nicely. The polish came out excellently, in my opinion. Maybe not 100% perfect, but still very nice for playing around. And so, while it may not be 100% perfect, and definitely not my new wedding ring, I learned a lot.
Well, that seemed to only go a little bit sideways. But the important thing is I learned a bunch of things about this. What to use for doing the bluing process, if I do want to continue trying that bluing process, as well as work holding inside the lathe, and how well the active tool post seems to work for the inside polishing. I also learned about getting the size just right, and honestly, I can measure this, and I know now that I have a standard that actually fits my hand. Going off just the sizing charts before was pretty close, but now I know what actually feels right. Anyway, thank you for watching, and be sure to check out my other videos if you like machining in a small home shop. Jesus. Oh yeah, there's your problem right there. Grade A failure to chooch. It just doesn't end. Definitely not good enough for the girls I go out with. Yeah, I'd say we can call this just not a skookum choocher. Anyway, keep on licking the mice.